So to hammer home the idea of the Sellinger algorithm, we'll work through an example. This is a 3-table join with a group by on the top. And let's take advantage of our catalog information on the upper right. The Sailors table has a B plus tree index on SID. The Reserves table has a clustered B plus tree on BID and a B plus tree on SID. And the Boats table has a B plus tree on color. Okay. So the best plan for each relation, let's say that for Sailors and Reserves, when you look at this query, there's no selections on those two tables, no single table selections. So the best plan for each of those probably works out to be a file scan. And of course, we'd look at all the plans and pick the cheapest, but it's going to turn out to be a file scan. Now notice that we have this B plus tree on reserves.bid, and that could be used in the join of r.bid and b.bid. So that's an interesting order, so we'll keep that. We also have a B plus tree on sailors.sid, which could be used in the join of sailors and reserves, and also could be used in the group by. So that's an interesting order. And on the boats table, we have this B plus tree on color, which is interesting because we can satisfy the selection predicate b.color. And that may simply be the optimal plan for accessing boats. So here's our dynamic programming table. The first two columns we have for sailors, the best plan is file scan. For reserves, the best plan is file scan. For boats, the best plan is the B tree on color. And then for reserves with the interesting order of BID, there's a B tree on BID. And for sailors with SID, there's a B tree on SID. Now in pass 2, for every left deep logical plan, that is to say, for every plan P in pass 1, and for each from table T that's not in P, we're going to join them together. So those are all the possible left deep logical plans. And then for each physical plan that corresponds to that, we're going to look at each access method on the right-hand side, T, and then each join method for combining the right-hand side to the left-hand side. We're going to generate P with that join method on the access method of T. So example, we might have a file scan of reserves as the outer, with boats as the inner, using some particular join algorithm. We might have a file scan of reserves as the outer, with sailors as the inner, using a particular join algorithm, etc., etc. And for each of these pairs, we're going to pick the cheapest plan for that pair of relations and an interesting order it might produce. And in the end of that, we might get a dynamic programming table that looks like this. It's got the single table plans that we had before, but it's also starting to accumulate 2-table plans, boats and reserves, boats and sailors, sailors and reserves. Not room to show all that here in the picture, but hopefully you get the idea. In pass 3, we'll be using the pass 2 plans as outer relations, generating plans for the next join in the same way we did with pass 2. So for example, we'll look at the best plan for boats, reserves, which might be a sort merge of a B tree and a file scan. And we might try to join that with sailors with a B tree on SID, okay, using, let's say, a hash join. After we get pass 3 done, we'll have all our tables joined together, and then we'll add the cost for the group by in the aggregate. And in general, that's the cost to sort the result, unless we have an interesting order that's already previously sorted. Finally, we'll choose the cheapest plan overall amongst all the join orders with the possibilities of sorting or not having to sort for the group by aggregate.